Okay, so let's start with the properties of screening test. Properties of screening test, right? So in the properties of screening test, basically we are talking about, two important parameters, right? Now you need to be with me, guys, for understanding this particular topic. Okay, so in the properties of screening test, we have understood screening. We have talked about the types of screening, right? We have talked about what is lead time, screening time, and we have talked about the latent period also, right? We have talked about the, for the criteria for the screening test, right? We have talked about the validity, we have talked about the accuracy and the precision as well. Now I'm going to talk about the properties of screening test. In the properties of screening test, basically, let's say that this is the population. Okay, this is the population basically, right? This is the population, and let's say in this population basically this much persons were healthy, right? This much persons were healthy. Okay, so this is the reality, right? This is the reality. So this shows that this is the reality. Okay, this is the reality. Basically, these persons which I am showing over here, these persons are basically healthy, and these persons are actually having the disease. These persons are having the disease. Okay, listen to me very carefully. Okay, this is the reality. Now what happened is basically that we are having a test in the market. For example, there is a test for COVID-19, right? There is a RT-PCR and there is a RAT, for example, right? So there is a test, right? Okay, or you might say that there could be the pregnancy test, or there could be different kind of test, right? So there is a test. It is also having some particular important parameter, right? Different tests are having parameters, right? So if the RT-PCR test is coming positive, right, or I would say if the RAT test is coming positive, does it mean 100% that you are COVID positive? It doesn't mean. Or if the RAT test is saying negative, it is telling you that the results are negative. Is it 100% true that you are COVID, you don't have the COVID basically, or you are COVID negative? Okay, is it 100% story? No, it's not, right? Either if we feel that the person might have the COVID basically, so we are actually moving on to one step ahead and we are going for the RT-PCR test basically, right? So why is it so? Because we know that yes, the RAT is not having that much of specificity, right? It is having high sensitivity, but that not much specificity. So we are going for one step ahead and using the RT-PCR test, isn't it? So guys, over here, let's say that this is the test, right? Let's say that this is the test, and this test is showing this kind of result, right? It is deviating bit from reality, over here. The cases which are falling in this category, still we call them, okay, still we will be calling them this category, still we'll be calling them positive. So they are called as true positive. They're called as true positive. TP means true positive, right? The person who are falling in this category, they will be called as what? And the person who are falling in this category, they will be called as what? So here in this category, they will be called as true negative, and in this category they will be called as, look, these persons were healthy, but because of this test it will be showing them positive, so it is called as false positive. And the persons who are landing in this category, they will be called as false negative. How I am saying so, guys? You know that the person, I told you that, look at the reality, right? Above people I wrote with purple, those were disease positive, and other than that all of them were healthy. Now we are running some test over here, that is, this line is actually showing, the red line is showing that this is the test, this is some kind of test basically. Okay, this is basically the new test. Okay, we ran some kind of new test, it could be any test. According to this test, whatever people are falling in this category, okay, in this category, they will be called as false negative. Okay, they will be called as false negative because in actual reality they used to be disease positive, right? They, in this category persons also, they should have been disease positive, but this test is not covering this. Look at this line, this test is not covering this kind of people, so they have become false negative. Over here the test is also covering and the reality is also covering this category, so they will be true positive. This category, the test is not covering and person were already healthy, so they are true negative. So true positive true negative, you understood this. But over here we have talked about false negative and false positive. False positive means according to the test the person is positive, but in reality the person is not positive, the person is negative. Here false negative means in reality the person was having the disease, but according to the test they are coming negative, right? So it might happen. So this is the story. According to this story, guys, according to this story, here I'm gonna make one more table. I'm gonna make one more table, guys. So please be with me over here, right? I'm just making one more table, guys. Okay, one more table. Here on the top I'm writing the person who are having the disease. Here on the right side I'm writing the person who is not having the disease. Okay, then here I'm writing the persons who are actually tested positive, who are actually tested positive, and here in this line I'm writing the persons who are actually tested negative. Okay, so basically that is the thing. Okay, now just writing this thing. Okay, just be with me. Over here I am writing these persons will be true positive, and here I am writing these persons will be true negative. Here I am writing the persons they will be having false, they will be false positive, and here they are false negative. Okay, just writing this thing. Okay, based on this particular table, this particular diagram, I just wrote this thing. Okay, now how this kind of table will be working for you? Okay, on the basis of this particular table I will be deriving some formulae which you need to remember. They are actually asked in the exam very frequently. So what are these formulae, guys? What are these formulae? These formulae are these. Okay, so very first one I am deriving, that is what is sensitivity, right? What is sensitivity? Okay, for deriving the formulae what I will do, okay, I am having two sides, guys. This is the table. Okay, this side I am saying disease positive, this side I am saying disease negative. Okay, I will not mix these two sides. I will be talking about, at one time I will talk about this side, at one time I will talk about this side, either on this side, either on this side. So look at the sensitivity formula. Sensitivity says, sensitivity, which is also called as SN in short, right, abbreviated as SN. Sensitivity says that true positive, the person who are true positive divided by true positive plus false negative, right? So here I put true positive, here I put false negative, right? So true positive divided by true positive plus false negative. So did I cross the table? I did not cross this table. Okay, just remember this simple rule. Fine. Now next formula which I can derive out of it, that is the sensitivity is done. Now next formula which I am gonna derive is, that is specificity. Okay, specificity simply means, guys, specificity simply means, it is abbreviated as SP, right? So over here specificity simply means, look at this one, this is true negative divided by true negative plus false positive. I will not cross the table again. So true negative divided by true negative plus false positive. Okay, so true negative divided by true negative plus false positive. Okay, or I can write these formulas as true positive divided by, if you will see, true positive, right, true positive plus, right, if you will see sensitivity, I am saying true positive by true positive plus false negative, right? So if you will see, here is the true positive, this is the false negative. If I will combine this, right, if I will combine this, it means these persons were disease positive, these much persons were disease positive. So I can write true positive by disease positive, and here also I can write true negative divided by false positive by true negative. False positive plus true negative, false positive plus true negative, this is disease negative. So I can write it as disease negative, isn't it? Now next formula which I can derive over here, after sensitivity, after specificity, I can say false positive error rate. Okay, what I am saying, false positive error rate. False positive error rate, what is it? False positive error rate simply means, basically, look, this is the false positive, this is the false positive, this is the false positive, right? So false positive divided by false positive plus true negative, false positive divided by false positive plus true negative. Okay, so false positive by false positive plus true negative. Again guys, false positive plus true negative, right? This is the false positive, this is the false positive, this is the true negative. So this became disease negative. So in the denominator I can write false positive divided by disease negative again, right? I can write disease negative, right? And this is inversely proportional to specificity, because what was specificity? Specificity was true negative by disease negative, or true negative by true negative plus false positive. So this is just opposite to that. So we are writing 1 minus specificity. Okay. Next formula which I can derive out of this, that is the false negative error rate. Okay, false negative error rate. Again in the numerator I will write false negative. Where is the false negative? This is the false negative. So false negative divided by false negative plus true positive. So in the denominator I am not crossing the table like this. I am crossing the table like this only, right? Okay, so sensitivity true positive by true positive plus false negative, that is the true positive but disease positive. What is specificity? That is true negative divided by true negative plus false positive, right? What is false positive error rate? False positive divided by false positive plus true negative. What is false negative error rate? False negative divided by false negative plus true positive, isn't it? So this is the table. So I am playing with the table like this only, not like this only. Okay, so that is the case. So false negative divided by false negative plus true positive, that will become false negative divided by disease positive. Okay, and this is just inversely proportional to the sensitivity. Okay, right. Now two more formulae I am going to derive over here, that is what is PPV, and sixth one that would be your NPV. So PPV is your positive predictive value and this would be your negative predictive value. Okay, so positive predictive value says that, this is the table again guys. I told you we are playing with the table like this. Okay, but in the positive predictive value and the negative predictive value, what we are saying basically, that here in this case we'll be using the table like this. Okay, we'll be using the table like this. So here that is the case. So now for the positive predictive value, we are saying formula is true positive. Look at the formula. Okay, true positive for the positive predictive value, true positive divided by true positive plus false positive. Okay, and for the negative predictive value, I will say true negative divided by true negative plus false negative. Okay, so positive predictive value and negative predictive value will play with the table like this. So over here, positive predictive value, we are saying that it is true positive divided by true positive plus false positive, that will become your true positive divided by tested positive. Shall I write it like this? True positive divided by tested positive, because these two sum up will be called as tested positive, right? So I shall write over here that will be your tested positive. Okay, here also I shall write that true negative divided by true negative plus false negative. Okay, and that will become your true negative divided by tested negative, right? Tested negative. Okay, so that is the formula of your negative predictive value, right? One more point you should remember that, okay, that is the noting point over here. Note that positive predictive value is directly proportional to prevalence. Very important point. However, positive predictive value depends upon sensitivity also, specificity also, right? But very important question, positive predictive value is directly proportional to the prevalence, right? It depends on the prevalence. So if the prevalence will be increasing, if the disease will be increasing, we have talked about the incidence prevalence already in the previous chapters. So if the prevalence will be increasing, automatically the positive predictive value will also be increasing. Okay, so very important question, please remember that. Okay, so this is your MCQ. Fine. Okay guys, once we have once we are done with this particular important properties of this particular screening tools, right? Properties of the screening, basically screening test. Now we shall move on to some more important screening and diagnostic tools, right? So let's talk about some important screening and diagnostic tools now. Okay, screening and diagnostic tools. Okay, right, screening and diagnostic tools. So in the screening and diagnostic tools, basically we are talking about two important factors, right? What are these two important factors, guys? First one is that is false positive error rate. False positive error rate. Here we have talked about false positive error rate, false negative error rate, right? So here I am writing again false positive error rate. What was your false positive error rate, right? Guys, till now you should have told me false positive error rate. I told you already that was your false positive by disease positive or disease negative. It was your disease negative. So false positive divided by disease negative, if you guys remember. Okay, so that was disease positive box, that is disease negative box. So false positive divided by disease negative, that was your false positive. And if I will tell you false negative error rate, false negative divided by disease positive, or false negative divided by false negative plus true positive, right? So if I am talking about the false negative error rate, then you should have answered me false negative divided by disease positive, isn't it? False negative divided by disease positive, right? So that is the story, isn't it? So over here, what shall I write? Over here, what shall I write? You know, if there is an error, related to the false positive error rate, then in that case you will be saying this is the type 1 error. That is my point. Type 1 error, which is also called as alpha error, because alpha comes first, right? Here, if they are talking about the error in that false negative error rate, then you are talking about type 2 error, or it is also called as, after alpha what comes? Beta. So that is the beta error. That is all. If they're asking you what is the error, which kind of error which will be seen in the false positive error rate, you will be telling that it is the alpha error, or you might be telling it as type 1 error. Okay, same likewise in the type 2 error you will be seeing false negative error rate. Okay, now next point over here is that what is telling the seriousness of an error? Is it false positive, which is a serious error, or is it false negative? So guys, false positive is serious error as compared to false negative, right? If you talk about the seriousness of error, then false positive is serious error as compared to false negative, right? False positive is also error, false negative is also error, because false positive, what it is telling? Unnecessary, it is telling us positive, right? Patient is healthy, person is healthy, but your test is telling it is positive, right? And what is false negative? The person is basically diseased, but your test is telling you that the person is having negative results, right? So that is also not good, right? So these are error, both of these are error. But what is the bigger error? The bigger error is the false positive error as compared to the false negative error, right? Okay guys, now moving on to the different point now about the screening test. Okay, so there are two tests in any kind of disease. We are talking about two tests. One is the screening test, another one is the diagnostic test, right? First of all, let's say the patient with the abdominal pain is coming to you, right? You will be going for the ultrasound of the abdomen first of all, right? You are not ordering bigger tests, right? You are not ordering for something like colonoscopy in the patient. You are not ordering for the endoscopy of the patient, right? Directly, right? First of all, we are going for the USG whole abdomen, and then we will be getting the bigger picture in our mind, and then accordingly we will be going for the investigation of choice or further diagnostic test, right? Okay, right. So if you talk about the screening test, guys, okay, if you talk about the screening test, then in the screening test, basically we are saying that this particular screening test, what are the properties? First property is that it should be having low false negative rates. Second point is, here the sensitivity is used as a screening tool over here, right? That's why sensitivity is used as a screening tool. So if it is having the low false negative rate, that's why it is used as, hence it is used as screening tool. Right? For an example, I gave you the example already, right? That is your example, that is your USG whole abdomen, for example, right? So you are actually going for USG whole abdomen. For example, the person was coming, the pain, the person was coming with the pain in this particular region, right? Okay, in the lumbar region, I would say. So in that case, USG whole abdomen, you are going for renal calculus. There might be the renal calculus, right? So you are just going for the USG whole abdomen, right? But still, if you want better test, you might go for the NCCT KUB, NCCT kidney ureter bladder. That will show you the better picture, obviously, right? So that would be your diagnostic tool. Okay, so for the diagnostic or the confirmatory test, okay, so I'm writing over here. For the diagnostic or confirmatory test, what should be the condition? Diagnostic or confirmatory test, right? Diagnostic or confirmatory test, what should be the condition? Okay, for the diagnostic or the confirmatory test, the condition is, again I'm using the same color over here, right? The condition is the person should be having the test should be having the low false positive rate. Here the test should be having the low false negative. Here I'm saying the low false positive rates. Okay, the next point, so that's why we are using it as specificity tool. So hence it is used as diagnostic tool, hence it is used as diagnostic tool, right? Okay, so that is the thing. So what could be the example over here? Again guys, same example, NCCT KUB for renal calculus, right? For renal calculus. So basically point over here is that the person should be having the low false positive rate. As far as diagnostic tool is concerned, the person should be having the low false negative rate. Okay, low false negative rate, that is for the screening test, right? And low false positive rate, that is for your diagnostic test, right? And at last, there is one concept of combination of test, guys. There is one concept of combination of tests. Combination of test. What is this combination of test, guys? In the combination of test, basically we are talking about, I will just take red color. There is one scenario, for example, scenario 1. There is one scenario 1, and there could be another scenario, that could be the scenario 2. That could be the scenario 2. Okay, in the scenario 1, okay, I'm just taking the test. Okay, for example, the person comes to you, the patient comes to you, right? And you did this test also, that test also, this test also. Okay, so you are just doing the multiple test, for example, CBC, LFT, KFT. Okay, all of those tests you are actually doing for that particular person at the same time. So you are actually ordering the test, for example, test A, test B, test C, for example, CBC, LFT, KFT, ECG, PTNR, okay, and USG whole abdomen, you are going for the chest X-ray also. So different multiple tests at the same time only, right? One scenario could be this. This is the scenario 1, that all of these tests are done at the same time. All of these tests done at the same time. This kind of testing is considered as testing in parallel. This kind of testing is considered as testing in parallel. Okay, so this is called as testing in parallel, right? Easy, guys, right? For example, multiple tests are done at the same point of time. For any kind of patient, that would be the testing in parallel, and we are doing very commonly basically in the casualty, right? We are running this test also, that test also at the same point of time. And now basically if the person is in ward, for an example, and you want to rule out bigger kind of diseases, right? So for example, in those scenarios, what you are doing, you are just, first of all, you are running test A. Okay, you are having, what you are thinking, you are having particular scheme in your mind. Okay, and with that scheme you are actually running the test in your patient. For example, you did the test A. Okay, and what you are thinking, if the test A will be positive, I will be having my diagnosis. In case if the test A will be negative, then I will be going for test B. In that case. Okay, then I will be going for test B in that case, right? If test B, okay, so test B might also be having two kinds of results, that it could also be positive, it could also be negative. If it will be positive, I will get my result, I will get my diagnosis. In case if it becomes negative, then I will go for another test, that will be test C. Okay, and then again it might be positive, it might be negative, right? So if you are going for this kind of testing is called as testing in series. This kind of testing is called as testing in series. Okay, this kind of testing is called as testing in series, right? I hope you guys got my point. So one is the testing in parallel. It means multiple tests at the same time. If you're having the scheme in your mind and you are actually going for test one by another, okay, after this test then running another test, then running another test, depending on the results of the test, then this kind of test is called as the testing in series, right? I hope you got my point, guys. Now let's jump into the MCQs. Okay, whatever we have discussed, okay, let's try to apply that in our MCQs, guys. Okay, right. So now we'll be going into the MCQs, guys. Okay, fine. So let's look at the MCQ number 1. Okay, so in this particular MCQ, what they are saying, guys, they are saying true statement about PPV. What is PPV? Yes, that is your positive predictive value. Positive predictive value, right? Okay, now you should be telling me. Okay, by the way, tell me the formula, guys, for positive predictive value. Tell me the formula. Positive predictive value, what was the formula, guys? Yes, play with the table like this. So here it was tested positive, right? So in the denominator I can write tested positive. Okay, or this is true positive sign, rather I should write tested positive. I should write tested positive. In the numerator, what should I write? True positive plus here what should I write? That is false positive. So true positive plus false positive, right? Okay, so true positive plus false positive, that should be in the denominator. That is your tested positive. That should be true positive. So above you should be having true positive. So it increases the prevalence. I told you positive predictive value. It increases with, it is directly proportional to the prevalence. I told you it is directly proportional to the prevalence. Directly proportional to the prevalence. So if the prevalence will be increasing, positive predictive value will also be increasing. So is it decreases with prevalence or increases with prevalence? It increases the prevalence. So this will be the MCQ, guys. This will be the answer. Option A will be the correct choice, right? Either they can ask you the formula also. So this would be the formula. Okay, fine. Or you can write true positive divided by true positive plus that would be your false positive or false negative. That will be your false positive. False positive, right? So I shall write false positive. Okay, so that could be your formula either. Understood, right? Anyways, next question. Sensitivity is used to calculate, guys. So sensitivity, which is also abbreviated as SN, right? What was the formula of the sensitivity, guys? It was true positive divided by true positive plus in the denominator what you will be writing, that is your false negative. So that is your true positive divided by disease positive. Okay, so that was your formula. Here I am talking about what? I am talking about the true positive. So what should be the answer over here? That is the true positive, right? Okay. Next question. Predictive value indicating positive test in a screening modality is calculated by. So they are asking you positive predictive value. They are asking about positive predictive value. What is the formula, guys? This is the formula. You just need to apply either this formula, either that formula. So true positive divided by true positive plus false positive multiplied by 100. Okay, you can add that. So true positive divided by that. So true positive divided by false positive plus true positive. Okay, so this became your formula, right? Right? Okay, understood. So true positive divided by true positive plus false positive into 100. Okay, that will become your formula. Question number 98, guys. What is specificity formula? Very straightforward questions are coming. Specificity formula, which is abbreviated as SP. So what I told you guys in the specificity is your, so what is the specificity formula? Yes, guys. So that is your this kind of table. So this table and this table, right? In the table, this portion. Positive predictive value, negative predictive value, you are playing in the table like this, right? Positive predictive value, negative predictive value. For the sensitivity and specificity, and for the false positive error rate, false negative error rate, you are playing with the table like this, right? Like this in the columns. So they are asking you about the specificity. You will be playing with this column or that column? This column, right? For the sensitivity, this column. For the specificity, this column. So this column was for the disease negative. So true negative divided by true negative plus that was your false positive. So true negative divided by true negative plus false positive, or you can say true negative divided by disease negative. So that will become your formula. So over here just mark that answer, true negative. So true negative divided by, they are talking about specificity, true negative divided by true negative plus false positive into 100, right? So that became your answer. So true negative divided by false positive plus true negative into 100, that became your answer. Okay, so multiplicative factor in all these kind of cases, that will be 100. Okay, that will be 100. Okay, so let me write that over here as well so that you don't confuse also, right? So multiplicative factor, you just can add, that is your multiplication of 100. Okay, so there should be no problem with that. Fine. So I hope guys you got the basic idea basically. Okay, so that was about the screening test, right? So in the next module I will be talking about the biostat, and I will be starting with the biostat basically, right? So thank you so much for sparing your time in this module, and I will see you in the next one. Thank you.